Kerala State Higher Education Council for giving me an opportunity to interact with you all people. Of course, what I'm going to speak today is the relevance of interdisciplinary research in technology development. In fact, my post-graduation as well as my PhD both are in zoology and entomology. Meanwhile, I qualified AARS, Agricultural Research Service, and I became the scientist in this stream of ICAR, Indian Council of Agricultural Research. But I did not confine my work alone in my own field because the technology which I developed, we developed not less than a dozen technologies. Those technologies I could achieve only because of the interdisciplinary research approaches. And usually people ask, interdisciplinary approach is feasible only for the scientists who are in the stream of science. Absolutely not. What I learned from my experience, we should have the linkage even with some others and other subject as well as no, some what you call different languages also from Malayalam, English, Tamil, etc. like that. I just wanted to quote a simple example here. In the Malayalam, there is one famous Kerala Karshagan. In that, I have been writing one series of article. Its Malayalam name is Moidunimasham Kuttigalum. Its eighth has come now, and this has got a very wide appreciation and publicity. Ultimately, what happened is other people are also asked me, means my friends from other state, they wanted to translate this into their their local language and publish it in their journal. So this is a science, purely science, particularly about environment and institutional application. How does it work? So ultimately, what I did the same thing in different language. You can see here in Tamil, in Marathi, in Bengali. This is simultaneously now going on. This is purely because of my interdisciplinary approach. One simple example for this one. Now we are going to make this is in 13 languages now. 13 languages. This is achieved only because of that one. And also, we developed the technologies, the production of biopesticide and not less than 10 products from a waste tapioca leaf. And the biopesticide which I formulated by using this technology got wide acceptance among the farmers, not only in Kerala, but the entire, not only in the state, not only in the nation, even from abroad. Later I thought I made certain videos, and those videos I prepared in different languages, including Russian. The first one is in Russian. This also I achieved because of the interdisciplinary approach. So this is Russian is there, the Kannada, Telugu, Malayalam, Tamil, all languages we made it like that. Absolutely, I did not spend any finance for this one. I just approached the people who are in the field. The Russian one scholar, I got introduced from the one place, and I requested her to make the script. She did it. Then I went to the Department of Russian here, the Kerala University, not Russian, the history department. I had one. I learned there is one Russian scholar, one student is there. I approached her. I took her to the studio. Like that, this became my dream became cherished. So this is the way what we have to do in interdisciplinary research that is not confined to science alone. And also yesterday I had a brief talk with the Rajan Gurukul sir also. No, I am a zoologist, I'm an entomologist, particularly my specialization in insect pest management. To study this insect pest management, first we should know about the pest. Under that, we should know where the pest has come. For example, in the case of Periplanta americana, you must have learned in your SSLC or some other classes. Periplanta americana is nothing but a cockroach. I'm well aware about this group is an heterogeneous one. That is why I am, as far as possible, I try to avoid all the scientific jargon. This is only layman language I'll speak. So this Periplanta americana, that pest has reached here from America somewhere else. How did the pest reach in India? We have to find out its root first. If you're able to find out the root exactly, we may be getting some solution to control the pest. The typical example now I wanted to say, there is, you can see that in your plant, in your crop, in your garden, there is a white substance and white fly. One is mealybug, other one is a white fly. The fly was introduced, somehow accidentally introduced to our country from abroad. Later we realized this has come from this particular country. So to control, there is a natural mechanism to control that pest, their area. There are certain predators, there are certain enemies. So if you know well about from which country this has come, easily we can go to that country and find out what is the natural enemies available there. We can bring it like that. We did it now. So this work can very exactly can be done by an historian rather than a zoologist. We can ask him, so what is the way the food has come? The food migrated or traveled all the ways through which are the areas? Probably rather than a science, when biologists, an historian must be the right person to talk to give a feedback about this one. Like that, in every area, you should have the an interdisciplinary approach. Then only we'll be able to produce certain technologies, viable technologies. Here, what I wanted to say about the technologies which I developed here, and how did I achieve this one being a zoologist? How did I achieve this one? I just, with an example, I will explain it. This is nothing but tapioca. My dear friends, hereafter I won't say tapioca. Tapioca is the name, or maraschini is the name being used only certain pockets of the world. Widely, this is known as cassava. Cassava. So hereafter I will use cassava. Cassava means nothing but tapioca. As you're aware, tapioca is an important crop, not only in Kerala, not only in India, throughout the tropical countries. The crop is being grown, and over 800 million people, this is the staple food. The cassava tuber is the staple food. So the sago, you must be knowing sago, chowari. Sago is nothing but a product of cassava flour, tapioca flour. If you go to Tamil Nadu and Andhra, those areas, there are hundreds of factories running day and night to produce this sago from cassava, tapioca flour. So when we visited those areas, again, that is again the interaction or the interdisciplinary research like that, when we approached again Tamil Nadu Agriculture Universities and Agriculture Department of Tamil Nadu, when I visited those areas, there is lot of waste. After the harvest, at the time of harvest, what they will do is they will just clip the top portion of the plant and thrown as a waste. The top rest only we use. You can see here the rest only they use. The top portion they will take and thrown as a waste. Rest only they use as the planting material. So this waste alone, if you just calculate, that is around 5 tons per hectare. 5 tons per hectare. My dear friends, you should remember in India, the cultivation of cassava is 1.72 lakh hectares. So how much quantity of the leaf we are thrown as a waste, that we have to know some insight about it. So what happened? And the cassava, what I told about cassava, all the things, and then I thought we went this the sago factory. It's a big, huge factory. They won't permit us to take the photograph from inside. This is the outside photo only I have taken. It's a huge factory, and in day and night, and lot of waste from cassava, tapioca leaf, as well as the tuber rind. That those are the pure waste out of that one. So the technology I told you know, the interdisciplinary in the sense, not you look alone, the academician or researcher. Researcher in the sense everybody is a researcher. If you go to a village and ask some mama, some grandparents, grandma, they are doing better research than us. Probably they are not generating data, that is different. So I know very well about my childhood, particularly tapioca was our staple food. That is a poverty stricken time those days, and many times our life totally depend upon the cassava tapioca tubers alone. So some tubers are very bitter because no, that is the cheapest one available. So such a bitter tuber, if it is available, my mother used to do how to cook it. She used to cut it very, very small pieces. And after cooking, she used to decant the water once or twice and remove that water. You see how beautifully she has done it. You know what is the big science behind it? Probably my mother would not be, my mother did not know. The compound what is she is thrown out is cyanogen. And those precursor molecules are linamarin, lotosrin, etc., etc. Despite she knows the technology very well. So the first thing what we want to researcher, if you wanted to generate some technology, go to the village, interact with the village people, and you can learn many things from there and bring back to the lab, the land to lab. You perfect it if it is needed. Like that, my mother told those days the cassava leaf, tapioca leaf, it is eaten by the cattle that will be killed. So they took extreme care to avoid feeding or grazing the animal, the crop. So I realized there is a toxic substance in that one which is responsible to killing the animal. Why can't we use such a molecule to control the insect pest? That was striking in that was a striking point in my life, in my research field. So what I did, so this is, I don't want to explain it because I know the people are from different disciplines are there. That's why I don't want to explain the terminologies here. But this is in nutshell what my mother did it while she was cutting the tuber into small pieces. What is actually happening is this one. Because I'll just tell you a brief about it in simple language. You are well aware about a cell. What are the cell organized? That nucleus is there, endoplasmic reticulum, ribosome. These are the names you've already heard about. In that cell, there are these type of plants are called cyanogenic compounds, cyanogenic plant, because cyanogen is the active principle in those plants. Not only cassava, there are over 3,000 plants are having the same molecule, including your apple. Apple seeds has got cyanogen. Bamboo tip used to make pickle, that has got cyanogen. Then the rubber leaf shoot is got cyanogen. Siamese is got cyanogen. There are over many plants. So it's not a molecule to be afraid of. That is, one should realize it. Don't get panicked. Cyanogen, what is potassium? No, it's not a potassium cyanide. It's a hydrogen cyanide approved molecule only. So let me see what my mother thought about this one. Why my mother chopped the cassava into small pieces to get rid of this toxic principle. So I told about in the case of a normal cell, all the things like nucleus, endoplasmic reticulum, mitochondria, this thing, that thing are there. But in the case of cyanogenic plant, there are additional certain packets in each cell. That packet containing a chemical. The chemical, those who are interested can just note down, that is called linamarin chemical. So these are in the packet. As long as they are in the form of a packet, they cannot produce any toxic principle. So to produce the toxic principle, what is required? That should be cut. When it is cut, when the tubers are cut, the compound linamarin comes out. Then there is an enzyme on the cell wall that's called linamarinase. Because of the action, ultimately it forms the bitter part. We feel the bitter principle is cyanogen, HCN, hydrogen cyanide. This is water soluble. That is why our grandma asked us to decant it frequently. That is the reason for decant it frequently. And why my mother, I've seen that my mother, what she used to do, if the tapioca is too bitter, she used to make very small pieces. And the decanting she used to do twice while cooking it. What is the science behind it? While cutting very small, more and more packets of the linamarin will be broken, will be cut, and active principle comes out, dissolved in water, and it goes out. And mother used to cook the tuber in open condition only, open earth only. Another science, because its boiling point is very less, 35 to 37 to 80. So just by cooking it escapes out. So these are the technologies we get from the interaction with other people or other people. And now what we did from our research, cassava tapioca, usually we used to make tubers alone. So my 35 years of research, I'm about to retire now. I'm 62 now. This May I'll be retiring. So during my 3.5 decades of work, what we did by using this cassava, the after harvest, after taking the tuber, the leaf we use for the extraction of biopesticide, extraction of biofumigant. The biofumigant means in the godown there are a lot of storage space. You must be knowing that when you purchase the pulses or rice or wheat, whatsoever it is, and stored in your kitchen, within 1 month you can see a lot of insects are coming out that one. Where does it come? When you purchase the grains, rice, wheat, whatsoever it is, there are egg stages, larval stages in the kernel. It takes almost 30 days to complete its life cycle and comes as its adult. Fortunately, we used to consume it before it adult comes. That is why we are not knowing about it. But if that is kept unused for 1 month, this adult may emerge out. So that is the action. So almost 33% of our food product is lost during this post harvest, after harvesting and in the storage. So to control this pest, usually in the godowns, FCI godowns or warehouse, what usually used to use, there are chemical fumigants like the methyl bromide, then aluminum phosphide like that. But all those chemicals are banned because after that Earth Summit. Because these chemicals are making deterioration not only in the atmosphere but the human being as well. And it is a major killer of the ozone layer. So all the fumigants are banned now, phased out now. There is no fumigant to control this particular pest. So from cassava leaf, the cyanogen, it is highly fumigate. Its fumigation effect is very quick. One of my PhD students, Dr. Ajesh, he got PhD out of that one. He did this work and ultimately he isolated the biofilm from that and compressed in the cylinder that we can now use as a fumigant, the biofilm. So after extraction of the bioactive principle, whether it is insecticide molecule or some other molecule, because we have isolated not only the insecticide molecule, we isolate other molecules also. Molecules, the remaining part we use as a biofertilizer, which is a biofertilizer. Then from the cassava leaf, we isolated certain molecules which are having pharmaceutical values. You won't believe these molecules have got anti-cancer property and the antivirus, including corona. This is not my work alone. This is a written document I got from the Israel. Yes, I have a group of Hebrew University. This is their research, and they now approach us for a collaborative work, the compatible compact. And also the cassava leaf has got the capacity to control the mosquito larva. See, for everything we should have our own different types of formulation. The same thing, tomato you can make ketchup, you can make sambar, you can make chutney like that. Maybe tomato, but its combination or its recipe is different. Similarly, here also the active principle is the same, but different ways we may have to formulate it. And also it is effective against simicide. Simicide means to kill the bed bug, muta, bed bug. Yes, that also be proved. And to your information, to my surprise, later only came to know that cassava leaf or tapioca leaf contains almost 30% protein. 30% protein. The literature says that more than what is present, it's suppose if you take 100 grams of cassava leaf, dried cassava leaf, as well as 100 grams of a chicken egg, cassava leaf has got more protein than the egg. And there is one publication also, cassava protein is the best source to compensate the protein deficiency in the world. We are unable to utilize this protein because there are anti-nutrient factors like cyanogen. Know what we did? we isolated the cyanogen, we converted that into biopesticide, we converted to biofumigant. Now, the rest of the material is free from cyanogen. What's the principle? From there, are we able to isolate the protein? Or there is a huge mass of the cassava leaf after harvest. The quantity what is required for your preparation of biopesticide or so, rest you can utilize for the harvest of protein molecule. Then one of my students, one of Mr. Joseph, is writing the thesis. Yes, he has done a formulation, a very good formulation against the ticks of pet animals. Those formulations are, we have a tie-up with the veterinary university that is under screening now people. And off late, we isolate the biogas also. You may feel there are certain angles, certain people used to ask, what is new in that one? Biogas, if you put anything into the biogas plant, you will get biogas. Why do you want to go for cassava leaf alone? Why can't you use other leaf? Absolutely no, you cannot. That part I'll talk about it. So once we developed biogas, then we came to bioelectricity. My dear friends, here is the what two things I wanted to say here. This is a collaborative work with CTCRI, IIT New Delhi, BRC Mumbai, over and above one workshop fellow, Mr. Francis from Trichur, and also Jitendra Singh from Rajasthan. These two people really contributed a lot for making the machineries. And true, the bio-CNG also we made it, and they and while doing this one, I realized yes, we are able to produce the bioactive principle from cassava. I started this work in a test tube, then to beaker, then to cooker, then to autoclave. Then I realized it is possible. It is possible to make a machine out of it. So I visited. That is, here lies the importance of again interdisciplinary research, because I do not know the nature of the molecule. So I took 2, 3 very learned chemists with me. My own biochemistry professor, Dr. Nandakumar sir. Nandakumar sir's his PhD's guide was the student of a Nobel laureate. One. Second, I've taken late Iyer sir. Iyer sir was 1984, 85, 84, 85 when the Bhopal tragedy was happened. Supreme Court appointed him as the expert, chemical expert to identify the molecule. Like that, and Dr. Murthy from my own senior, Dr. Murthy from IIT. So, all with the help of all those 3 people, I studied about the molecule. So you just imagine about being a zoologist. If I think no, I should not approach these people, I have to do myself, I would not have reached anywhere. We did it, and ultimately we succeeded. And to make a plan of this one, I told you no, we visited the entire means wherever possible from Delhi to all the places we went to make a fitting machinery for this one. We failed miserably. Then fortunately, I accidentally told the stories to one of my seniors, one of my exactly like I treated him as my brother from PM Subramanian, PM Subramanian, the joint director of BSSC, who was very close to our APJ Abdul Kalam sir. His book also he mentioning about him. I told the story to him, my dear friends. Another lesson what I learned from you, from my research. See, to get the help, you should not hesitate to ask anybody. Don't think that how these people will think about you. No, you knock every door, one will be open for you. Absolutely. So I went to VSSC Prince Space Center and I met him and he called a meeting of some engineers. He asked me to give a presentation. What is my requirement? Accordingly, I given and that area, no, why did I go there? Because no, that is a place of our world guru. See, Abdul Kalam sir, he always used to say, dream, dream, dream. Dreams transform into thoughts and thoughts result in action. To attain your dream, certainly you should have an interdisciplinary research approach. Otherwise, it is impossible. It is fragmented. Okay, then I went there, we made, and with their support only, This is the first generation biopesticide machinery we developed. This is the first gen. Now it is a museum piece because it's the first generation. From this, what are the defects from this one? Accordingly, we were second generation. Now we have a third generation, that is the commercial model. We made it, that is to get our technology. Not less than a dozen company from India and 5 from abroad approach us. This is achieved. This is not my work alone. I cannot claim for this one. This is a collective work of all my students are the foreigners. Along with that, the other department. See, nearby, even the BSSC, then CSR Institute is there. That's called, those days it's called RRL. Now it is called National Institute for Interdisciplinary Science and Technology, NIST. Then Srijita Tirunal Institute. Then Rajiv Gandhi Center for Biotechnology. Not only locally, almost all Indian institute, wherever possible, wherever I require this help, I approach, I got help. That is why I reached up to this level. And we developed 3 biopesticides, Nanma and Masraya. Most of the farmers among you sometimes must be knowing about this one. This is the demand is not only from Kerala, even abroad. They ask, recently abroad they ask this product. And that is about the biopesticide. Now the biogas, what is recently we did, very recently we did, and probably yesterday's newspaper, you might have seen this one, this news, NATO Mike Gaveshna Kendram, and just probably now it is airing that one air. Just now only the interview was the interview was over with me, some radio joke, something like that. Now maybe it is broadcasting now at this time. This is the one which he did. The from the cassava leaf, ultimately we made bio CNG, and we are driving my vehicle also along with that one. My students are there, and in that one. So earlier what we did, see, I told you about why cassava leaf alone, why can't other one? That is the question. I will come later. So first we realize from cassava leaf, yes, it is possible to get biogas from that one. And those days we know only about biogas. You know the biogas what we are using now. In that biogas, almost 50% is 50 to 60% is only methane. That's good. If the methane content is above 50, that is economically feasible. It is above methane. Rest is carbon dioxide. And the very fortunate thing for us is that our biopesticide doesn't contain certain toxic principles which are otherwise you can see the biopesticide what in the when you use other sources as feedstock. Feedstock means what you are feeding it is called feedstock. For example, in your house, we used to put as the biofeed like the wastage of rice or the fish curry or meat curry, meat whatsoever it is. That only we used to feed in the biogas plant to produce the gas. We will never put leaf into that one. If you put too much of leaf, that is the end of your biogas plant. Here, there's some science is lying behind it that will come later. Why is it so? So we learned very well that cassava leaf, after the extraction of the bioactive principle from the leaf by using our machinery, the rest of the solution, the rest of the waste slurry is well fit to collect the biogas, particularly large quantities of the methane. Yes, credit is equally shared by NIST, Dr. Krishna Kumar, microbiologist. He only did that part. I'm so proud of him. He only did that part. We'll come to that one. And this you can see that after that, this we published, and this was a and those days the newspaper. This is 2019 January 5th. We inaugurated by Suresh Kutukulam, a famous agri writer, agri scientist. Those days the Indian expert, I mean Hindu one news has come from pesticide to fuel the bio way. That bio way. Those days we were able to produce biogas only from the gas. Only biogas. That means the biogas is a combination. It's a compound contains methane, carbon dioxide, and other gases. That much only. Later I realized I got a thought about it. Is it possible to scrub off or remove the carbon dioxide from this one and make the methane pure? Then efficiency will be very high. So how to scrub it off? I do not know. I approached this our CET, Government Engineering College of Engineering Trivandrum. Incidentally, my co-brother is a professor there, and I met the concerned division, and we got some hint about it, but they are in the infant stage about it. So I got an access to the IIT Delhi. IIT Delhi, I went there. I was there for a few days. In fact, I went IIT Delhi to make our biopsy in a nanomolecule. I went there. And my batch ARS, Agricultural Service, one Dr. Sunil Ghare, he left our ARS and joined in the IIT as the professor, and he is the still he is the dean of the department. So I contacted him and asked, I wanted to come to your lab. He's a well-known biochemist and this biotechnologist. And I asked him, I wanted to meet you to test or to convert my biopesticide into nanomolecule. Is it possible? He asked JP, you come there. I was there. I was staying that campus. That campus, can you just imagine a zoologist can enter into that campus? But I was there enough to enter that one and met this fellow, this my friend. 1 week almost I was there, just like a student. I was also working. It's a very good working atmosphere, culture there. Until 8 o'clock, 9 o'clock, people used to work hard. Students used to work day and night there. That one has to learn from the culture, from the IAC, IIT, BRC, Bombay. These three places really, I so much appreciation. Later, I found this culture in CU, University of Kerala also. Okay. Then I discussed these people. Then at the end, I asked him. So my work was over a little early because I kept it for the incubation. Time was there, so I don't want to waste my time. I asked, hey, Dr. Gare, can I visit some of your other department? But careful, I cannot understand the terminology, what they speak. I wanted to go some places where they talk, I should understand. Is it any department here? He said, JP, I'll take you to one department car, Center for Agricultural Rural Technology. Yes, he took me there and he took me that place. And if I buy use certain technologies here, all these are the biogas, biofuels, the things, technologies here. So I asked, is it possible to use cassava leaf also? They said cassava leaf, not only cassava leaf, any leaf is a difficult task unless until it has to be subjected to pre-treatment. What is pre-treatment? I'll tell you later. Okay, from there, this I learned purified gas from the cassava leaf. You can see here, we succeeded. And once we succeeded in this one, then my interest was, is it because I scrubbed the carbon dioxide, the entire carbon dioxide, I could scrub it and I could make it 100%, not 100%, near to 100% purity of the methane. Then I thought, is it possible to compress the gas in the form of LPG cylinder so that we can replace the cylinder with this one? Yes, we succeeded. This cylinder, what you can see here, is the same one only. And we are using now my laboratory. Now we are using this gas as a cooking gas. Then I thought, then again I went back to IIT. I went there and asked about the story. Then I asked, is it possible to make electricity out of this one? That was my next one, and bio-CNG, next one. So I know very well that, I know my presumption was that cassava leaf is not a good source to produce electricity or bio-CNG, despite I can try. So those days, what was happened is, I told you about my student Joseph. He formulated a veterinary drug against the ectoparasite of an animal and certain birds. That is his PhD work. To validate that one, we went to agriculture university, the veterinary university, Manuti. And that time, he and his wife, Cincy, both Joseph and Cincy, also she is also my student. We were staying in the campus that evening. Cincy got an interest to see, is there any Deshi cow here nearby in this campus? So my co-brother is a teaching faculty there. I called him, I took him, and we were roaming around, and I found there is a big biogas plant in their campus. My biogas plant, its capacity is only 1 MQ, but they have 30 MQ very big biogas plant. 30 MQ means every day they have to put 30,000 cow dung as the feed. And it's interestingly, I found that they're able to produce 5 kilowatt of energy out of it, electricity out of that one. My dear friends, you can see one Joseph, Francis is standing here, Francis. Then immediately I asked, who is the professor behind it? Who is working this one? I asked my co-brother, he has given me his number, I called him. So my intention was, this is one of something if you find, you have to think about, is it possible to emulate, is it possible to just copy or just do something feasible out of it in our research also. So I called this Francis, and I asked him, why are you using this copper sulfate here, this one? He said, it is scrapping the carbon dioxide. I said, no, it's not possible. Then he asked me, who are you? Then I revealed myself about me. Meanwhile, I called my, then he told, this is scrubbing the carbon dioxide. So I'm not a chemist. I called my chemist, Dr. Rajeshwari. I asked her, Rajeshwari, they are using this copper sulfate to scrap the carbon. Is possible? Rajeshwari told, no, sir, carbon dioxide cannot be. Probably they wanted to scrub out this H2S and other gases. So when I conveyed this one, he was so immensely happy. He came and he met me that night. It was night. And by 7 o'clock, 8 o'clock, I was about to go my friend's house. Meanwhile, he called me, said, sir, I wanted to meet you now. Okay, then you come because he's an aspirant. He has got some interest this way. So I canceled other one. Some 2-3 hours we discussed. I had given him some advice and he was immensely happy. And my intention was, is it possible to use cassava leaf as a source of energy for electricity? I know it is not possible, but I asked the Francis, I have an ambition in my life. That is it possible to use how much quantity of cassava leaf, tapioca leaf is required just to know one filament, just to burn once? How much is required? Can you do that work for me? Because I already made biogas out of it. I already scrubbed this one and made the pure methane out of it. He said, sir, these are the people you will never forget those people. He is a businessman, but he told, sir, because of your sheer interest, I will do this is for you the free of cost. He said, I will do it free of cost. He asked me, are you able to get me some money to purchase what you call the generator? Generator new one is 30,000 rupees. 30,000 rupees I can give from my project, but it takes time. So 1 second that generator will do that cost only 5,000 rupees. I gave them. I also went to his house, in his workshop. We made some modification, everything. Ultimately came there. We made the biogas, the bio CNG out of that one. You can see now I am riding my bike using that bio CNG. This is my director and head in charge, and we are using that. He is the Francis, and that also I achieved not only because of the IAT part. This fellow also played a big role in that one. Similarly, the Rajasthan, that Singh also played a big role in this one. You can see here, this is the electricity we produce, and we have given its name, the Kasadeep. Kasa means Kasava Deepam. And this has come to different newspapers, all the newspapers, TV, everywhere. And this is my lab now. This is flooding the light, all this with cassava tapioca leaf. This machine is producing the biopesticide. That waste is going to this slurry, this biogas plant. From there, it is coming here. There's a lot of, you can see scrubbing unit, then biogas reservoir, then methane, the what you call drying unit. There are many steps in that one. If you're able to visit my lab, you can see everything. So we succeeded this bio-CNG plant only because of the collaborative work or interdisciplinary work. And incidentally, day before yesterday, the Mahatma Gandhi University aptly recognized my work, and I was given the Scientific Innovation Award. Or day before yesterday, was a big function there. And now, will you believe that one? From 1 ton of cassava leaf, your monthly profit, I'm talking about profit, not expense, not principal amount, the profit alone will be 338 to 508 lakh That means 3.38 to 5.08 crores from 1 hectare, one ton of leaf, cassava leaf. To get 1 ton of cassava leaf, I already told you, in Kerala condition, when we harvest cassava, we are getting 5 tons per hectare. But if you go to Tamil Nadu, the biomass is much higher, 10 to 15 tons per hectare, because we never used to irrigate the crop. They are raising the crop by irrigation. So the biomass will be very, very high. It's very high. So 1 ton leaf, how much area is required, you know? Just 20 cents. Just don't point, don't 20 cents, 50 cents. 0.2 hectares only required. From that, our profit is 3.38 lakhs if we utilize our technologies. But cassava is a 10-month crop. So once you harvest, okay, 0.5 cents if I cultivate, once in a year only once you can run your factory. Now we made it. Now I tell you how did I get it? I've arrived this one. It's okay, leave it. This is the biopesticide. From that alone, we'll get 331 lakhs as profit. This is, you can see here 200, 300. You know what is that one? Suppose we enjoyed. So some people told the factory usually will run 200 days a year. Some people told it is 300 days a year, because this proposal we wanted to submit to the policy makers, including Tamil Nadu. So we made a proposal, we made a calculation. Suppose that the factory runs for 200 days, how much is the profit, how much is the area to be cultivated, everything. Or rather, if it is for 300 days, how much it would be. So you can see here, if it is 200 days, how much area to be I'll tell you later. The biopesticide alone, the profit will be 3.31 crores to 4.97 crores. And bio CNG, if it is 200 days, you will get 14,800 rupees biogas after extraction of the back principal cassava leaf. And the tuber, as you know very well about the cassava tuber, tapioca tuber, now its cost is not less than 30 rupees. And the cassava tuber, and also, you know what is the productivity of cassava tuber? Not less than, say, the national average is 31 tons per hectare, but even 100 tons will get. That's a potential yield. 100 tons will get it. I just put only 10 rupees per kg, and just no 10 per kg, and from I calculate like that, and I put the cost of the biopesticide 530, and that is the I just put only 5. We are selling our biopesticide. The cost of 1 liter of biopesticide is 530 rupees only. Its production cost is even only 200 rupees. We are getting almost 50% of the profit out of it. Being a research institute, we should not earn profit. That profit you are going back to the development of the plant here. Why did we put 530? Because this month, January 4th, I made a market survey. I found that any insecticide, you won't get less than 1,000 rupees. Some exemptions are there, certain cases, 1,000 rupees per liter, the insecticide. Particularly if you go for organic, it goes even 1,800 rupees per liter. At the same time, our Nanma cost of Nanma, that biopesticide is called Nanma cost, 560 rupees alone. Its impact, if you wanted to learn, you ask the farmers, farmer will tell you. You can cheat a person only once. Repeatedly you cannot cheat. You ask how many times the farmers used to approach us for suppose the product is not available, they'll be mad. And this is all this is happened because of, say, my trust is always here in the interdisciplinary research. This everything happened because of this. Even this part also, I took the help of economists to calculate the economics. And this is the chart we made. Suppose if we wanted to make only 1 ton of cassava leaf for your preparation, I told 1 ton you will get 331 lakhs, but once it's a 10-month crop, once you harvest, tomorrow where do you go for this leaf? In that case, you have to ensure every day cassava leaf. And that case, suppose if it is 200 days, you have to, this is for 300 days. So 0.2 hectares is required for getting 1 ton leaf. So for 300 days, 0.2 into 300 means 60 hectares. Suppose if you plant 60 hectares, that means equal to 150 acre of land. Every month profit will be from the cassava leaf will be 3.31 crores to 4.97 crores. And accordingly, according to your capacity, you can go 10, 20, 30, 40, like that, even 100. Suppose 100%, 100 tons, if you wanted to use, you have to plant 6,000 hectares of cassava. Probably you may ask, in such a huge area, is it possible to plant? Yes, it is possible. People are planting like that also. I'll reach that one. And this is the bio-CNG from the, in addition to the bio-CNG, from 1 ton, your profit is, per month profit is 61,000 as in the case of 300 or 40,000, the 1 ton. This is in addition to the biopesticides. And like that, we made it like this one. And so this is, we put only 60 rupees as 1 kg of the bio-CNG. I asked one driver, he said he's purchasing 80 rupees per kg. Okay. And I told him we develop electricity also. Just 1 ton of leaf, you're able to produce 952 units. In my house, the monthly consumption is only 250 units. Maximum consumption is 250 units. So just from 1 ton of leaf, see all this work we did with the help of our own electrical engineer, all this calculation. And this is for, suppose if it is for 300 days, you're using your factory is running for 300 days. Easily from 1 ton you will get 1.5 kilowatt, 1.5 units of monthly kilowatt units, 1,500 units of electricity you can produce every month. Now the question is, I told about, is it possible this 4,000 acre or the 6,000 acre, is it possible? You may ask the question, is it possible? You just see the scenario of Indian cultivation. In India, the latest record, the Source Horticulture Board latest record, if you look at the production is, total production is 1,782, 1.78, 1,72,820 hectares of land is being cultivated by cassava in India. Of that, 90,000 is, or 89.610 is in Tamil Nadu alone. In Tamil Nadu alone, the cultivation is Tamil Nadu alone, and it is almost, it is 51.8%. Kerala cultivates only 31.6%. That is almost 54,000 hectares of land. And Tamil Nadu, see the 89, already they have 90,000 tons. See, even for 100 hectares, 100 tons of leaf, how much we require? Only 6,000 hectares of land is required. And if we just imagine that only 5 tons per hectare, I told about this Kerala condition, Tamil Nadu, just double or triple. You will get not less than 4.48 lakhs of leaves. That means in Tamil Nadu, for 4.48 lakhs of leaves are thrown as a waste every after harvest. And I just calculated, if from that one, if you are able to utilize only 10% of the leaf, total 10% of the leaf, your profit from the bio-CNG and biopesticide, everything will be 8,91,603 lakhs rupees. Just 10% of the waste leaf is being utilized. This is the estimate, 10%, 20%, like that. We have made it. And what are the advantage over this one, cassava leaf? Why can't we use other material? One thing, I have visited many biogas plants and industry plant also. Recently, I visited Rajamandri. The feedstock they are using poultry manure as the feedstock they are using. Recently, there was a report in Namakkal where we are getting the eggs. That is half of the eggs business. But 8 tons you have to recover every day. 8 tons of the poultry waste litter is recovered every day. So the place where I went in Andhra Pradesh, that factory was closed down temporarily because of the non-availability of the feedstock. So when you use the cassava as the source for bio-CNG, Advantage is abundant availability of the feedstock. Then no threat to food security means, this means there is a there is a legal binding here. Food crop should not be used for any industrial purpose that will affect our food security. Even from the food crop rice, one should not prepare alcohol out of it. That will affect the food security. So a crop is being considered or identified or recognized as the food crop should not be used for the industry purpose. That's a world, the rule. That's the rule. That is, here we are doing, this is a dual effect what is happening here. We are collecting the cassava leaf alone, which is thrown as a waste. That's a typical example for waste to wealth concept, number one. Number two, because of this what we call lucrative business, people will cultivate more and more area of cassava. So ultimately, we are getting more and more cassava tuber also. Means we are strengthening the basket of the what we call food security. We're strengthening there also. So both ways are there. Then the weak linkage, alpha linkage, that I'll tell you later, and no requirement of pre-treatment, that I'll also tell you later, and no corrosive gas, in the sense I told you. The biogas which is produced from cassava leaf, it is pure because this is hydrogen sulfide and ammonia are the toxic principles. Usually it's a corrosive nature. Those who have biogas plant in your house, you are well aware that the stove we may have to repair, replace very frequently because hydrogen sulfide and ammonia will destroy your destroy your the biogas plant. Okay, why is it so? Because the feedstock what you are giving is an animal origin, maybe fish or the meat. The sulfur containing compound which converts and may make hydrogen sulfide H2S and ammonia. Both are corrosive and toxic principles. But luckily, cassava leaf is a plant origin. Absolutely, there is no hydrogen sulfide and ammonia. This is a test what we have done in NIS, CSR Institute, NIST, Trivandrum. And also this technology, once it is completely whatever success, it's already successful, the technology can be taken into 195. This when you look at this the starch, I told you about, it is its subunit. The base unit is sugar. The sugars are linked together and form the form of a garland. That garland is called starch. And the thread, what is used to link each and every molecule, that's called, we call it linkage. Linkage is very weak. That's called, it is alpha linkage. What is the alpha linkage? Alpha linkage is very easy to break down. That is why when you put this macromolecule like the starch and other things, rice and other things into the biogas plant, immediately the alpha linkage will be broken and form this biogas. But in the case of plants, the plant leaf, there is no starch there. Instead, what they have is the lignocellulose compound, lignin, cellulose, like that hemicellulose compound. Interestingly, whether it is starch or cellulose, the basic structure is same, glucose only. Both are same, the basic structure. The house is constructed by the bricks alone. Difference is one part you use mud to stick on one by one to stake it. You use mud, other place you use cement. Similar way here also. In the case of starch, the glucose are linked together by 1,4 alpha linkage. Alpha linkage is very weak. So it will be broken, it will be cut into pieces very quick, and once it forms the monomer, the sugar, it gives the biogas very quick. But in the case of cellulose, its linkage is beta. Beta means very difficult to cut it. Example, you think about a garland. The flowers, here, take the flowers as the molecule of sugar here. And if it is the garland is made using the common thread, usual thread, the cotton thread, just in the flame itself, that will be broken, and all the individual flowers will release out. But same flower, if you use some very tough polythene, I mean, Tangis thread or so, that's very strong. Though the basic molecule same, the bondage is, the linkage is different. That is very difficult, very hard to cut it. So what is required there? There, the what you call the cellulose and hemicellulose, if you are able to break this beta linkage, not only beta linkage here, there is cross linking also. So this is very tight to ensure its strength. There are linkage from other side also. So it's very tight. Is very difficult to break down into its monomer, single monomer unit. That is why we found not impossible, difficult to get gas from leaf. Leaf, when you feed it, it's very difficult to convert into gas because of this linkage problem only. So what is required? There lies the importance of the pre-treatment. Pre-treatment. When I went to the IIT Delhi, when I discussed those people, they said they're free research purpose still they are using it. They are using to break down the beta linkage. They are using the treatment like acid or alkyl. They're using it to break down the compound, the linkage. Once you use acid or so, there are different types of treatment. You can go for a physical treatment, chemical treatment, radiation. And when he was explaining this, he said thermohydral treatment also possible to rearrange the molecular structure. When he just told about thermal, hydrothermal, immediately one what you call one struck in my mind. Idea reached my bonnet. In that case, while extracting the biopesticide from cassava, the same energy is being used there. That case, is it possible the material emerging out from the cassava leaf to be used as a source of biogas? Reaching back immediately, collected the waste after extraction of the bioactive principle. I collected the waste. I took I took into this. My friend is the director of those days, the NIS, Dr. Ghosh. I went there. I discussed with him. I told, you just see this one. Is it possible to make gas out of it? This is a waste after extraction of the bioactive principle from cassava. My this one waste, is it possible, Ghosh? He just transferred that material to their microbiology lab. My dear friends, here lies the importance of interdisciplinary research that has gone to microbiology lab. Professor Krishna Kumar, my friend, principal scientist Krishna Kumar, he asked me one thing, sir, your aim is to extract the insecticidal molecule from cassava. And from the waste, if you're getting only 10% of a gas, it's a profit for you because your target is the bioactive molecule, insecticidal molecule. Yes, Dr. Krishna, true, that's true. That what he told is true. You know what had happened? Then next day he called me and told, sir, usually in cow dung only we expect 60% of methane. This is surprisingly, this has got 60% methane. Not only that, there is no, yeah, these are the chemical treatment. There is no, you can see here, this is the most modern analysis of a compound, GCMS. And he said, there is no, absolutely, there is no hydrogen sulfide or methane. It's a wonderful molecule it is. That way only I did it. I took the material and converted it here. Then this is when this came to know about my technologies. The government engineering college, that team, Dr. Swarnalata and team approached me, and they got one project to make hydrogen cell out of the FC, the fuel cell out of it. Hydrogen is one out of it. And we had a discussion. Hydrogen also we are able to make. This also had a discussion with the IIT people because I don't want to tell about the scientific aspects here, but there is a possibility of making hydrogen also from cassava leaf by different methods. Now we are having a collaboration with this. We are thinking about a collaboration with the CET, and the few days back, January 5th of this year, few days back, the Hindu, the main news was this one. This is the prime heading, the title of this, the capital. The title was this one. Center clears 19,744 crores for green hydrogen mission. So cassava leaf has also got a better better birth in this project. This has come to that one. So this is possible only through this one. And then I searched the major bio CNG firms in India. Government is giving 2 crores rupees one-time grant to this one. Government is now encouraging bioenergy like anything. So Mahindra plant, if you just type it yourself in the Google, you can see that Mahindra plant. If you look at here, Mahindra plant, they are collecting 8 tons of the daily feed, 8 tons every day, collecting 8 tons. My dear friends, you imagine every day we have to get 8 tons of the food waste. This is the food waste every day. And also the food waste, when you bring it, that thing what I told you about, because the start you have to do pre-treatment, as alkaline treatment or some other treatment you have to do it to release or to make it monomer, a single unit. And from 8 kilogram of the daily feed, they are getting methane 400 kilograms. So I told, if you can get 7.84 tons of cassava leaf, it is as equivalent as you are feeding 8 tons of this your feed material, the feedstock. Feedstock, are you able to ensure it is everyday it is available? I do not know. Maybe if it's so well and good. And its equivalent cassava leaf is 7.84, for which how much area is required? 1.6 hectares only. And I made a comparison. I collected all the bio CNGs in India and how much energy they are producing per day and how much equivalent cassava leaf that could be replaced and what would be the profit. Here, you can see, for example, Greener Biogas Private Limited, they are producing 163 TPD. TPD means tons per day urban waste. Every day they should get 163 TPD ton per day urban waste. So they'll be able to produce 6,000 kilogram of this one biogas, I mean, the renewable natural gas RNG per day. That very well you can replace if you are able to give 118 tons of this cassava leaf, and the total profit in that case will be 2,360. This is I collected all the firms, the major firms of name and equivalency of their feedstock is given, and for which how much area to be cultivated also I have made. And this proposal we are trying to give to the policy makers in different countries. And this is a place very recently, October 14th to the 22, I visited in a biogas plant along with my friends from the CET, College of Engineering. My team, we visited this bio-CNG plant, Rajahmundry, Andhra Pradesh. And their feedstock is poultry manure. But due to lack of the poultry manure, that factory was shut down, maybe temporarily. But I told them to ensure the continuous availability, incessant availability of the feedstock. They can go for even the cassava cultivation because Andhra Pradesh cultivation cassava is also there. And the cyanogen can be used for insecticides. There is another top. When you do research, there are a lot of frictions. See, swimming along the main stream is easy, but swimming across or against the stream will be difficult. There may be friction. You may have to face many things. So the main thing what I faced, cyanogen, you are using cyanogen insecticide. Is it possible to use cyanogen insecticide? Cyanogen is an approved molecule. This is not potassium cyanide. This is HCN only. There are umpteen papers. This is a recent one paper. Cyanogen is being used as an best alternative to synthetic insecticides. Moreover, now almost all synthetic fumigants, they stop the what you call in use. So this is the best things to use it. And internationally, they are using this one. And to the suppose and this I don't want to say, and the biopesticide which we develop are very effective against banana. Banana pseudosporium weevil and different. In banana, there are 2 types of weevil. One is affecting the pseudostem. You can see that. Another one is affecting on the rhizome. There are two types of one. So both looks alike. So two of my students are given to work, and both looks alike. Both look alike, but there are differences. And you can see this one, and these are the weevil. This is the fate of the plant later. And at the time of the infestation, you can see that exudation of some liquid like this, some secretion. And there, if you inject our biopesticide, that will get wonderful result. And farmers used to get wonderful result. They are using, I told you, use the syringe, usual syringe for the injection. So farmers told they're getting very good result, but there is one bottleneck. One problem what we are facing is, suppose we are using the common syringe, common needle, because of the fibers, it starts, it clogs, and occlusion will be there. So one needle cannot be used for further more banana plants. So that's a problem for us. That I learned from the farmers. So I took this issue. I went to many places. Ultimately, one engineer from KVK Trivandrum, the Trivandrum, one Dr. Mr. Adin, he only developed a particular syringe needle. That needle has got multiple holes. Now you can just punch it. That delivers your biopsy in different places. That I don't want to speak more about it. Now the farmers are using the one. Widely they're using it. These are this before treatment. You can see before treatment, after treatment is complete drain out. So this is lot of results we got it. And another technology, because of this one, what you call the interdisciplinary, what had happened is, usually farmers used to put a lot of furan at the time of planting the banana plant. I am always with the farmer to know more about, because they are my real gurus. I learned many things not from the book but from the farmers. So the farmer told, here is their presumption, the concept there. What they are thinking is, the pseudostem weevil, that's Malayalam is called Tadapulu. Tadapulu that is the end of the plant, the crop. So they told at the time of planting itself, they used to put a bunch, the handful of the Frodan into the plant. And unfortunately, Frodan is a systemic plant. When you put it on the bot, on the down, on the ground, it goes to the true stem, that is called Unipindi, Varapindi, Varatada, and also the fruit, because it's systemic one. So they are applying at the time of planting itself. Then I told my student, Dr. Jitu Negation, now he is the scientist in KFRI. Jitu, I have given this as a topic to him for his PhD works. Very bright, very brilliant, very what you call diligent worker. I told Jitu, the plant must be emitting some chemo signal to invite the pest from faraway places. There is a chemical signal happening that one. You just find out what is the chemical signal when it emits, when it comes out that way. And he did a wonderful work. Every month after planting, he approves the plant, make a homogeneous solution by using different insecticides, different solvents, polar or non-polar, this thing that will make it. And he did a particular work here that I don't want to explain here. And he realized the plant will be releasing this chemical only 4th month after planting. Before that, no, absolutely not. This is coincided with at the time of forming the inflorescence. At the time of inflorescence, at the axial region of the plant, there is a group of bacteria. That bacteria produces some metabolites. Just like our sweat goes, the pest can only detect from faraway places and attract towards this plant the poisoning eggs. That is the way. And we isolated the compound. We studied. This is also a big chemistry work. We did this is with the Bangalore, our own institute, NBAIR Institute. We realized what it is. And this is because of a microorganism. Again, we took the help of a microbiologist. Now we learn. We told the farmers, your intention is to curb, to control the pseudostem weevil. Don't apply any insecticide at the time of planting. Up to 4 months, your plants are intact, absolutely no problem with this pest. Maybe some other things. This pest. And now we made and some people both are looks alike, and we made a package by using our own pesticide. Farmers are widely accepted that one to control this pest. Another student, because both are same, it looks like alike, rhizome weevil and pseudostom. One is on the rhizome, Vadatadapudu. Other one is pseudostom, Vadapindipudu. That one, it looks alike. But the funny thing is that this rhizome weevil is always in the rhizome only. It cannot go up, cannot climb on the pseudostem. But other one is just reverse. Why? What is the reason? You find out that one. Again, we took the interdisciplinary research and we found that in the case of pseudostem weevil, they are having their lug, or it's appendage, or you are telling lug. At the tip of the lug, it's a very small one, tip of this electromagnetic study. There are certain mechanisms to hold, just like the lizard, how it goes, how it moves on the atop the roof. Similar mechanism here in the case of this one, you can see here. But in the case of other one, it is brushed-like. It won't get any grip over that. That is why it fails to move over that. Like that we learned, we understood what it is, because this also we learned because of the administration. Now people are widely using our biopesticide to control this one. You can see here, and this biopesticide is also very effective against the red palm weevil and the coconut. And the top of the one tree, on top of the coconut tree, to demonstrate how to apply our biopesticide to control this pest. By realizing this one, years back, in King Abdullah University of Science and Technology, world famous King Abdullah University of Science and Technology, otherwise known as COUSAT. 1985 onwards, this is a major pest of date palm in Saudi Arabia. So they invited the scientists from different countries. India, I visited, and I found the insect is attacking on the trunk only mainly. And they have an X-ray capture system also, but it's not required. By using our biopesticide, this will easily be controlled. And immediately after that one, the chairperson of the King Saudi University invited me for a collaborative work in their area. Even they asked this, even they asked our technology for this purpose. And very recently, 2022, there are a lot of people from outside India are approaching us for our technology, our product. And next, come to the, I'll give you a break after 10 minutes, okay? And as regarding to the biofumigant fumigation, I told you about the godown. Is it possible to fumigate this one in the godowns to control the stored product pest? We have taken a work along with the FCA people in here Trivandrum, in the Karakutam FCA godown. We have taken our product and we did an experiment, extensive experiment here. And I realized it is impossible by using our pesticide in this condition to control this pest, because the active principle was dissolved in water, this aqueous medium. Even if it is that after the evaporation of this active principle and kills the pest, since it is in the aqueous medium, water will absorb, attract the fungus. Though you are able to kill the pest, that will attract the fungus, then your products will be contaminated. So as such, you cannot use it. We realize that one. No, it's a big failure. We cannot use as such for the control of the biofilm as a biofilm to control this pest. So I took my next student, Dr. Ajesh, is a teacher now. Ajesh, I asked him, are we able to isolate the gas alone from here and compress it in the form of LPG cylinder, carry that cylinder and release into the garden? Is it possible? Yes, we did it by using that one with the help of a DRDO defense project. Now all the containers, cylinders are having the same one. And the very interesting thing is that in just before Corona, I was in Berlin, Germany for an international symposium. In that symposium, what was happened before that, I was in Vancouver, Canada for other international symposium of entomology. There only I came to know the storage products in the symposium is there in Germany, but the last date to submit the abstract was over. But I made a plead. I just sent a letter to those people because the date is already over. Can I get a opportunity to present my findings? I sent my abstract also. I got a letter from those people because everything is over. But since might be the reason, abstract is okay, that reason is good. They said, shall we give you a postal presentation is okay, we'll support you everything, the travel and everything, will support you. And I said, okay, well, good enough, because I wanted to see some people and interact those things. When I went there, in one section, mine was a poster only, poster. I put my poster there and I was listening the one lecture in one hall. There, this one company in Russia, Drasloka company in Russia, his presentation was the blue fume, means HCN. They are the largest producer and supplier of hydrogen cyanide HCN into the world for the fumigation. And they are using as a fumigant. They are the world's largest supplier of fumigation. And they said, and his talk was, he concluded his talk saying that now we are planning to isolate the same molecule from cassava. It was a thunderbolt, it was a shock to me. He said, we already done it. We compressed, we have filled into the cylinder also. Immediately after this, after his talk, I took him, I went him, met him, took him. Luckily, the poster was lying there. I took him and shown the poster. You see my poster, you can see here. Management of the major polyethylene paste of stored products using the incidental principle, I was so immensely happy after seeing that one. And after getting my patent, the same company now asked technology from us, cassava leaf. You see, a crop which we thrown as a waste, from there we are getting very active molecules like this. Okay. Then from there was one Malayali scientist also. In fact, she was Dr. Kavita. She was also a scientist in ICAR. Of late, she left and she started her own the agro firm in Dubai. She's the biggest unit what that called Euroclean. They are the government's biggest fire protection agencies. And she said, she asked me one thing, sir, is it possible to control the bed bug by using your product? Because in the Middle East, bed bug is the major problem. I said, I do not know, we have not done it. Is it so? Incidentally, there was another talk regarding this bed bug only, management of bed bug only. So it was terrible to see even the shoe sole, when it was removed, the thousands and thousands of bugs was running here and there. When the window AC one just removed, encrusted the bed bugs everywhere it is. Immediately I called my friend, my student Joseph from there, and I asked him to collect the bed bug from the medical college, Trivandrum Medical College. I called the HOD of the medical college also. From the content ward, they collected the bed bug, and immediately from there, Germany, I instructed him what to do the research, what to do the experiment. He didn't send the data. I found, yes, it can kill, but we may have to make another formulation. It can kill. Then immediately the Euroclean, they submitted a project to ICAR, India government, for this one. What is about the pharmacology? The bioactive principle we isolated from cassava leaf, tapioca leaf, how best we can use it as a pharmacological agent. That's one. So this is, I told you about the cyanogen is the active principle and its precursor is linamarin. From linamarin only ultimately cyanogen forms. Okay. So our machinery that can isolate the particular segment, particular part alone, and uses it and we can make some pharmacological products. So what happened? So a few years back, when I just scanning the literature, I found that the anti-cancer property of cassava leaf, and incidentally there was one thesis also from Malaysia as well as Pittsburgh University. Their thesis is exclusively for the harvesting anti-cancer molecule from cassava. And interestingly, what I did, I collected the part from this one and sent to different places to test it. And the result, what we got is very encouraging. Yes. But one thing is that if you take any molecule, there would be some anti-cancer properties, but we are not in a position to push those molecules into the market because of various reasons. One, probably the extractability will be very poor. You know what is extractability? Means you may have to take tons of the leaf or tube, leaf or flower, whatever it is, to get the active principle. Ultimately, from that much quantity, you may be getting very negligible amount, ppn or ppb level. So that is economically not feasible. That's one thing. Second thing is extraction may be cumbersome. Third one, it is the economic, if you calculate, that is economically not feasible. So these are the reason why, despite the fact that there are innumerable compounds reported to have such anti-cancer properties, nothing is successfully seen in the market. Unlike that, cassava, if you look at, the leaf is available everywhere, and also extractability is also very high. Means from 1 kg of leaf, you will get immense quantity of this active principle. So after that, what happened is I took the active principle into, with the help of the Sri Chitra Kirnal Institute for Science and Technology, Dr. Mohan, the division head, my students Rijit and Joseph, they took this molecule there and they did a wonderful work. And we found, you can see here, this, I don't want to speak much about this because very complicated one part. One thing is sure, you can see that one, the cancer molecule gets diluted or destroyed when the quantity of the active, this is active principle from cassava. You can see 400 ppm, parts per million ppm. The live cells are very negligible. So this is what is happening. Everywhere, different tests we did it. All the tests as given. I don't want to explain this one because this heterogeneous group. All the tests shows that is very, very effective to control the cancer. And we published a paper in an international journal. Is impact of this cassava biopesticide as an anti-cancer molecule. By seeing that, and then and of late we got, and later we got a patent. By seeing this one, there is a famous company, Mycobra, from Israel. Those are, they have a very good tie-up with this Hebrew University. They approached us for the technology. We had a online meeting with these people, and they in that group they have some 4 or 5 scientists from here, myself, my director, and from Delhi, our deputy director general. We had a the online meeting, and we asked, what is your intention behind? You're asking the technology, what is the intention behind it? So one scientist said, see, my intention is to screen, to test, to validate your biopesticide in our place, the existing in our place. That is my intention. One scientist told so. And the second scientist told, I'm a mycologist. Mycologist means you specialize in fungus. Mycologist, I have isolated some chemicals called metabolite from the microbes, and that suppose if you add along with your biopesticide, does it augment the activity of your biopesticide? Yes. So I said, okay, one of my students, Mrs. Sinsim, she's working on these aspects. I can do it. The third one, he said, I am a medical physician, and my intention is to harvest the anti-cancer molecule from cassava. It was a shock to me because we also done it, and we also proved that one. It's an anti-cancer molecule activity. We said, of course, we also done it that one. But when I looked at these publications, they are about to make a medicine out of it. They reach up to that level. So pick what they done it. And the thing is that the linamarin they are getting from outside, from Philippines or so. It's expensive chemical, but the linamarin is immense in the plants. This is cassava tapioca plant. And they do not know how to isolate this from the plant. That is why they want to collaborate to work with us. And this was 2 years back. The meeting was held, and they submitted immediately. Immediately, one MOU they submitted. As per that one, I should be there in the laboratory for 1 year. They'll be here. Ultimately, the product, the success will be equally shared. That was the accord according to that one. And by that time, Corona was very high. Then file could not move. Still, it is not materialized. Later, somehow that was not happened. So what happened after getting this patent? I communicated to these people. I just told I got patent for my product, and I asked, what about your cancer work? How progress? How does it progress? I asked those people, and it was a wonderful thing that they said Now we found it is effective against coronavirus also. They said so. Coronavirus also. This is the letter God they sent to me. Yeah, you see like that of Jayaprakas. This one. By the time it is not Omicron before the Delta virus, they said cassava plant and tuber. They said that see approach the SARS coronavirus, novel coronavirus. The cassava may have bioactive antiviral, and they have done. They proved even it is effective against the SARS coronavirus, particularly the particular strain, Delta strain. And they have sent me the data also. They said now we are about to, they already made a lozenge out of it, a medicine out of it, and they are taking it to Rwanda for this human trial. They reach up to that level, but they were expecting the collaboration with us. They thought immediately they can collect large quantities of the linamarin from cassava and continue the work. But since the MOU was not materialized, they did not get it. Still, they are running with this the synthetic molecule. And he said, Jayaprakash, you only know how to extract it, but also join us immediately. But though the thing was not happened, we hope that may materialize soon. But one thing is that this is anti-corona property. I also observed, not against coronavirus it is. This is what I observed was the cassava leaf, which we use for extraction of the bioactive molecules, synthetic molecules, by using different varieties from our institute. In our germplasm collections, we have over 1,000 varieties of cassava here from different nook and noor we collected and maintaining here for our breeding purpose. So I, along with my chemist, Dr. Ajeshwari, we decided to screen this molecule, screen this plant, and see which variety produces more, gives more the active principle that we can go for large scale screening, large scale production of this bioactive principle. That variety we can plant it. Even otherwise, we are getting a lot. Still, out of curiosity, we did it. And we found, you must be knowing the cassava tapioca has got a disease. This leaf crinkling is there like this. This leaf is, leaf crinkling is there. This is because of virus disease. It's called cassava mosaic virus disease. But recently we released some varieties from CTCRI. Those are totally free from this virus. You can see here, this is very fresh, just like no healthy plant. There is no crinkling, nothing is the very fresh it is. This is the difference. But fortunately or amazingly, when we isolate the bioactive principles from this, we found that where the plant which is resistant to the virus attack, there the active principle was more. That gives us just a fact that gives us some clue in our mind that so wherever the bioactive molecule is very high, there is a suppression of virus also. This is in the case of plant alone. So I took the product to the Rajur Center for Biotechnology. That actor was my friend, is my friend. And we had because they have the coronavirus culture, the pseudo coronavirus culture. The pseudo coronavirus means that doesn't have any genetic material. The I have given, but unfortunately, by the time the concerned virologist got a director post in the Indian Institute of Virology, and he moved. So I stopped that. That means we also proved this is in the case of plant, but this company they proved this against this coronavirus also. So that means the virus and the plant, which once we thrown as a waste, could very well be utilized as a wealth with the help of interdisciplinary research. Then what about the ectoparasite of pet animals? We can see that's what I told about my student. He is working on pigeon pest, and he has got a good collections of the pigeons because he's a member of the pigeon club, and very good collections of that one. In this one, there is a pest on the body of the pigeon that is called pseudolingia canariensis. This is the pest. So when this is infested, the health of the bird will be highly affected, deteriorated, and this is a very severe problem. So what he did, by using our cassava biopesticide, he developed a technology, developed a formulation that we found, these are the collections what he had, that we found very effective to control this pest So ultimately, we took this product to veterinary university in Manuti for further screening and toxicology studies. So we were there one day, we were there staying there. Next day, while coming back, my student got a phone call from a breeder, the dog breeder. He said in his house there is a dog breed which has got immense. You can see here the ectoparasite, the ticks on the body of this dog, and he used all these chemicals. Irrespective of that, he did not get any cure out of it. That is a major problem on this dog. It's a very big problem the dog. So he asked me, can you just try something? So he is my student, Joseph. And together what had happened, I took OHP because now our biofumigant is easy to fumes out. So we we made a device. We took a OHP sheet on that. We made a layer of glue over that. We put some cotton. That cotton we impregnated the biopacet and just inverted so that over this above the surface will be the polythene, so it will not escape out, and tied over the body of the animal. And all the legs were so bad to see. That means interstate of the space. All the 4 legs, what we did, we took some polythene cover with our biopesticide and just put all the 4 legs in 4 bags. After 30 minutes, amazingly, we found it is all the ticks could be killed by using this R1. And this is against larvicide of mosquito. This student is from KVK, I'm sorry, KV, Kendra Vidyalaya, Cochin. He wanted to submit one project for this national, what you call, some exhibition. And he asked me to help him, and he came here because he wanted to test certain plant products against larvae as a larvicide against mosquito larva. And what we did, along with that, he has taken our biopesticide also, and we found our biopesticide is getting better result than the plants what he selected. And this is what I told about the protein in cassava. Cassava I told about now. Cassava meeting the global protein needs. Or this paper, if you look at nutritional value of cassava for use as a staple food and recent advances for improvement. This paper says that what I told earlier, 100 grams of cassava leaf has got more protein than an egg, equivalent weight of egg. So how to extract this protein from this one? That was our next objective. Again, I wanted to get a chemist, not only a chemist, he must be a protein chemist. So I was running to post for that one. And ultimately, we found a place that's called ICAR, our own Institute of CPET, Center Institute of Post Harvest Technology in Ludhiana. Almost 7 months back, I went there. I stayed there, and I was doing myself. And Dr. Yadav is the well-known, world-famous protein chemist. Along with him, we did it, and we could precipitate the protein from the cassava leaf. So that's the possibility is there. So because of his association only, I could do this much work. And these are the companies, they approached us for our products. The 7 companies from abroad, and not less than 1 dozen or so from India also here. And these are about my work on these particular aspects. Strategies in horticulture. Is it okay?
Okay.
Are you see the sweet potato?
Yes, sir.
Oh, okay, that's okay. Very good. You know, sweet potato, the CTCRI means Central Tuber Crop Research. Mainly, we are focusing on tubers alone here. So cassava, I told about it. And sweet potato, the tubers, you must be knowing well about it. Tubers. The tubers, sometimes when we eat, there is a bitterness in that one. So sometimes you feel a bitterness. The bitterness is because of there is one insect. That insect is called sweet potato weevil. Sweet potato weevil is just like an ant like this. The insect will deposit eggs on the surface of the tuber, or sometimes on the vine also, but usually on the surface of the tuber. Even it can go underneath and deposit the eggs on the surface of the tuber. Once it is hatched out, the plant will, as a what you call as a resistant mechanism, the plant will produce certain chemicals. That chemical we used to call tetranod. Forget about it. You just imagine some chemical they used to produce it. That chemical is the reason for bitterness. So even if a big tuber is quite big and your insect deposited the egg only one part, the entire tuber may get bitterness. So you may have to leave. So you may have to throw it out the tuber. So what we did, so our interest was that if you go and see in the sweet potato field daytime, you can't see even a single, you can see, but very rarely you can see the weevil. The weevils are seen only in the night time, not daytime. Nighttime only you can see that this is the infested weevil, you can see the infested tubers. And to control this pest, what has been used so far is, since this is underground, using chemical is a difficult task because of two reasons. One is the edible crop, we cannot use as it is. Second one, it is underground. So we have developed a pheromone trap. It's a trap. Pheromone trap, you must be knowing that we used to keep in the vegetable garden against fruit flies. Against fruit flies, we used to keep in the field. Similarly, we also have a pheromone trap. This you can see one can is there, one tin is there. Under that, you can see a rubber septum, one small rubber septum. The rubber septum is tainted or is coated with the pheromone. You know pheromone, what is pheromone? Pheromone means a chemical produced by one organism and its impact is from the same species, not different species. Means, suppose if I produce a chemical, only human being can detect it, not dog, not other one. That is called pheromone usually. Suppose my smell is being detected by another one, some dog is detecting. That's called chiromone. So same species means pheromone, another one means chiromone. Example, certain insects will release certain chemical as a sex pheromone to attract its opposite sex. So that chemical can be detected only by the same species. Some flowers will release some chemicals so that some flies will come for sucking the honey or pollination. That is chiromone because interaction is different species. These two things you please just note down. Similarly, we also have a pheromone trap here. That pheromone trap, if you keep, these all what you see is all are insect. But it is a male attractant. The chemical what we found, the insect is attracting, the male is attracted towards the female because the female is producing a chemical. So the chemical what it is, that is decoded, and the chemical was synthesized and put it in the rubber septum and kept it in the field there like a trap. Underneath, this is cut in all the four sides, or the other both sides will be cut. Underneath there is water. In that water, we used to put some detergent, also some oil or mild insecticide. So the insect will thinking that males will thinking that that is the female. Actually, that is smell of the female alone. Nothing is there. So all the males will attract towards that one and just fell into the trap, and that will be killed. So the philosophy behind is, so once we annihilate or once we sweep out all the males from the field, there is a depletion of the population due to the starvation of sexual starvation. There won't be enough male to mate the females. This was our thinking. But despite we used the trap for a pretty long period, still the population is same only. There is no much difference in the population. Population same only. What is the reason? So we found the reason behind it is that even if you keep the pheromone trap, only 80% of the male can be eliminated. So remaining 20% is sufficient to mate with all the females. Number one. Number two, the female population of this, but not only this one, in mainly, just like the Kerala population, females are more than males. Sex ratio, I think this is under 1000 to 1069 or so. Females are more. In here also, the males, females are more. If 100 males are there, suppose 100 males are there, means there are 105 females. So what is here? The reality you have to understand that while keeping the trap, if you are able to trap this many males in your trap, males won't make any harm into the field, into the crop. Adult won't feed much. adult doesn't make any harm to the plant. Only the females will come and deposit eggs. After hatching, that larva only destroy the crop. Otherwise, adult breeding is negligible. So this is what happened. That's called polyandry and polygamy. It means one male can mate overnight with 12 females. That's my experiment proved. Similarly, one female can mate at a time with many males. So the population, there will be an explosion. That is the reason, in spite of keeping the pheromone trap years together, there is not much difference in the population of these people. So what we did, now we realized we can do one thing. Even then we can use this technique in the field, because this you will get a clue about it. You are getting, by keeping this pheromone trap in the field, and if you suppose if you are getting 1,000 male, that is an indication given to you that there are over 1,000 females in your field. Take care. If you feel that okay, now we are about to harvest the crop, nothing is required to spray, nothing will happen to the crop, leave that crop, don't apply any insecticide. Or if the threshold once it is crossed, you go for the application of insecticide. So that will get it. So our interest was that what time actually the insect is very active in the field. That's my interest. This is a nocturnal insect, means it is coming night only. So what we did to find out that one, we did a wonderful work. It's a very interesting work, not a wonderful, interesting work here. That is, we selected 5 plots here. In the 5 plot, we placed the pheromone trap already. Then early morning, 4 o'clock, our team started, and we went to the field. We kept the pheromone trap, everything. Then every 1 hour interval, we collected the weevil's trap. Every 1 hour interval. This is continuously we did for more than 24 hours. Next day, this started today, early morning 4 o'clock. We terminated this work next day 9 o'clock only. We were in the field only. Every 1 hour, collect the things, bring it the pheromone trap, collect the things, bring back to the lab. You can see here 5 p.m., 7 p.m., night 9 p.m., night 11 p.m., night 1 o'clock, night 3 o'clock, then like that. Immediately the say 5 a.m., 7 a.m., like that, we brought into the laboratory. And one team will be in the lab. After reaching the lab, immediately we'll separate it, count it, everything, sort it and count it. And then this is a wonderful work. We got it, and we found the insect is very active between 7 to 11 p.m. Very clearly, twice we repeated, we got it. So this is very clear. The insect is very active between 7 to 11 p.m. You can see here now. And also how long it can fly, how high it can, because this is not a good flyer. So how high it can fly, that also we did. What we did, we kept it on the ground level, this one, then 1 meter above, you can see here, 1 meter above, 3 meter above, like that we found. And we found maximum it can fly up to 1 meter, but no, mainly it is in the ground only. Then 1 meter maximum you can go, the 2 meters, no, beyond 2 meters it cannot fly. So now we learned the behavior also, this one. And after collection of this, now we realized that, know what we did, no? We have given one insectigation technique, in the sense that now we realize the insect is very active between 7 to 9. Again, we approach one electronic engineer. We asked him to make a device. Automatically it should spray the insecticide between 7 to 9. Accordingly, we made one insectigation means, you know what is insectigation? Fertigation, there are 2 types of terminology: fertigation, insectigation. You know very well about irrigation and fertilizer application. Suppose the fertilizer is mixed with the water and irrigate together. At a stage, both will happen. You're irrigating, at the time it will get the fertilizer. That's called fertigation. Instead of this fertilizer, if you give insecticide, so while irrigating the crop, at the same time you're releasing the insecticide also and controlling the pest. That's called insectigation. So we did a work like this, we made it, and this is successful. This we can use it in the case of when we are using in the particularly in the poly houses. Like that, we develop one thing, and Another thing what we did, why the insect is attracting towards the plant. I told about it. That is sort of chiron. That means the plant earlier what we did that the case what the banana what we did the same way. We have collected the leaf, rind, tuber, vines, everything, and again in association with the chemist. Bear in mind, I'm a entomologist, I'm a zoologist. Associated with the chemist, we isolated the active principle in different chemicals, both polar to non our par level language with salt, polar to non-polar solvents. Ultimately, we found one chemical is very effective to catch the insect, what you call hundreds of insects we are able to catch, just like a pheromone. This is we collected from the field. You can see here, this is we collected from the field. The chemical, the bioactive principle is collected from the plant itself. That means the plant is attracting the pest, just like our pheromone. Thousands we are able to collect it. And what is the reason behind it? Because the plant is producing a chemical, it attracts its own enemy. Is there in the report elsewhere? I searched everywhere. In Nature, there was one report. According to that one, the the plant is releasing one chemical just to drive away its own enemy. This is attracting itself. So what I did, I just sent the letter to this because no, I again we told about what they call the disciplinary action. I had a good round of discussion in Indian scientists. Nobody able to decode it. So I sent to Prof. Davil, the Natural Resource Institute in the UK, because he is the authority in this field. And he said, your results are very interesting and impressive. The most obvious explanation is that the plastic traps were impregnated with sex pheromone. He asked me a question, had this trap been used previously with the sex pheromone or stored near lures of the sex pheromone? Means, he asked, probably the trap what you use, that trap earlier you were using with your pheromone trap. So the pheromone trap, the residue will be there in the trap. That might be the reason to attract the weevil, not because of your chemical. That's what he said. I said, okay, true. Because I myself confirmed that one. That is not the fact. Two things are there. Pheromone is a fumigant, just like what you call Chandantila Pogapole. Incandescence, it is what you call it. That this one, it escapes out very quick. Very quick, it goes out. It cannot retain there. So what I did, I've taken a pure, what you call a glassware. I washed, I sterilized. After sterilization, I kept the same thing in the field as a trap by using our chemicals as a trap. Like this, we kept it. Next day, we have taken this many catch, we caught it. That means this was not because of the lure contaminated. I sent this result to him. Then immediately asked, how did you isolate this active principle? There I stopped my communication. Okay, you can see that one. And then I sent to Cam Marshall. He is the man who is synthesizing the pheromone the worldwide. He also said, your findings that only males are attracted to the volatile of the host is not found in any other families of Korea. Means, and last is ending. In spite of my inability to explain your observation, it is important because it would lead a much better trap bait than is presently available. See, I wanted to know the mechanism, what it is. I've traveled length and breadth. I reached even JNU to ask this question. They said, this is a 10 thesis work. Immediately you cannot answer for this one. Okay, like that, I asked Norikuni. He is from Japan, is my friend. He said it is a big discovery, this thing, that thing. But still, I do not know what is the reason behind it, in spite of my inquiry with all these people. You can see here many people, Duke University, this one, Graham Thiel. In fact, this Graham Thiel is the FAO director of Root Tuber Banana section director. By seeing my work, he took me, he supported me, he funded me for a training program in South America. But still, this we do not know what is the reason behind like this. And again, with the help of the chemists and other people, we decoded what it is. Now, by using that, we will be able to. Yeah. the field. Yeah, this is the larvae of the sweet potato. Yeah. Yeah, this is the active principle. This is the active principle. Yeah. Yeah, he is my student. Both are my students. Now you can see in the field, you can't see even a single insect in the field. You see, there is insect, no insect. But when we keep this trap, you can see how cute the insects are attracted towards the trap. Yeah, this is the insect. You see, the insect feels it is a female. That is why all around India, this is pseudo mating. Insect is thinking that that's are female and pseudo mating. You see. Now you can see the beavers are coming from far away places towards that one. You see, all these are insects collected in the trap by using the chemical which we isolated. Yeah, this is a typical example for the interdisciplinary research. Okay. Yeah. No. So that's about the collection of the weevil by using the bioactive principle isolated from the tapioca, I mean the sweet potato. Like this, we would be able to make it. So these are some of the examples for our what we call interdisciplinary work. And this is what I told about the pheromone. Is it effective to control the pest? So far, we thought pheromone is effective to control this one, but we learned from our study, pheromone trap can not directly use to control the pest because of this type of fruit fly we used to keep it, but there are many loopholes in this one. So rather we can use this as a to count the population, how strength the population in the field. Accordingly, you can go ahead what measures to be taken, that one. Okay. And another work done by my student Sinsi, she's writing the thesis and she's sitting just in front of me. Sinsi, she see what she did. This pheromone trap can very well use some other way. She found that she has collected certain microorganisms, that's some fungus, that's called Bavaria bassiana, white muscardine, that's called generally called white muscardine. From different agroclimatic conditions she collected, and she found one strain is very effective to kill the pest. You can see here, that is the live one. When this is applied on that one, it will be killed very quick. Otherwise, the insect can live for 1 year, but when this fungus is, when the fungus comes in contamination, comes in contact with the other, that will be killed within 10 days. That is the beauty of this one. So where the all the details she did, electron microscope study, she did it, and how much, what should be the density required, and she found that even one infested male, if it is put along with some 400 females, it will be able to contaminate and kill it. So what is our thinking is, by using this pheromone trap, Anyhow, the males will not make any harm. So what we are doing now, we collect the males by using this pheromone technology. That males will be contaminated with this hair, the fungus. So within 9 days it will kill and there are fruit in body. That means contamination stage will be there. Using that one, she made one Silas card. Silas means Silas formicaris is the scientific name of this paste, and she made one Silas card. Now this card, because earlier in the pheromone trap underneath we used to put water along with surfactant. Now we don't want to kill the pest, let it go back, but it should be contaminated with the hair fungus. So the fungus carrying weevil when it goes back and mate with the female, the fungus will be transferred to the female also. Accordingly, that will also get contaminated and it will kill. That is the what she did it, and she put it in the field like that. Her work is over. This is what about I wanted to say about this pheromone work also. Thank you very much for your patient listening.